Hi, everyone. I'm really happy to be here in person for the first time at this event. So today I'm going to talk about some ongoing work that we are doing in the area of automated breakage detection. And this is in collaboration with Saeed, who is also here around and will also be happy to answer questions. He's a PhD student at EPFL, and Carmela. So in this work, we've been exploring the problem of breakage. I mean, you've already heard about breakage a bit from some of the previous talks. Basically, it's the loss of non-ad or non-tracking functionality caused by ad blocking. And I've just put a little example there for those who are not very familiar with breakage. So let's say that you have this web page, and then you apply some kind of an intervention on it. Here we applied uBlock origin, I think. And then you see that the main content, which the user actually wants to interact with, actually disappears. And this is called breakage. And ideally, you would want to minimize breakage, and this is something that is of a big concern for maintainers of filter lists, as well as the developers of ad blocking solutions. So we were interested in seeing if we could actually develop a solution that can automatically detect when breakage occurs, because right now there's a lot of manual effort involved in seeing whether breakage occurs. So you have to, visually inspect a page. You might need to interact with it to see if a particular filter list rule produces breakage. So before building our solution, we actually wanted to understand a little bit what were the existing problems with breakage, and what do users usually talk about when they report breakage. So we conducted a preliminary analysis of forums where people report breakage, and specifically we focused on these two forums. And one is this forum called EasyList Incorrectly Removed Content Forum, and the other one is uBlock Origin's GitHub issues. Now, I just want to point out that there are a few other sources where people may publicly talk about breakage. For example, you can have reviews of common ad blocking tools where people might complain about breakage. But we didn't look at those forums, and we focused on these two, because in these two forums, the maintainers of filter lists, they actually monitor the posts on these forums. And when they find an example of breakage, they visually, check the particular website, and if they think that this is a legitimate example of breakage that is caused by a filter list rule, they correct the filter list rule, and this happens via GitHub, and they post a link to the GitHub commit as a reply on these forums. So basically, we use the reply of a filter list maintainer with a GitHub commit as a sign that a particular issue is a legitimate example of breakage that is caused by an ad blocking rule. So we looked at these forums. In total, we analyzed about 1,779 issues from these two data sources. And out of that, we conducted a manual analysis of 525 issues. And so by manual analysis, we actually went to the website. We applied the particular version of the filter list that led to breakage, and we checked whether the breakage still occurs, what kind of breakage it is, and so on. And a few interesting issues that we saw was that the first one is that a quarter of the issues that we analyzed actually require some form of user interaction to trigger breakage. That means that if we need to develop any kind of automated system, that needs to involve some degree of user interactivity in order to trigger the breakage in the first place so that it can be detected. The second thing was that about 38% of the issues were actually caused by element hiding rules of filter lists, and which we'll see that is not covered by existing solutions, many of the existing solutions that try to measure breakage. So any kind of detection system would ideally have to cover both network blocking as well as element hiding rules of filter lists. And the most important thing is that only about 44% of the issues that we manually analyzed are still reproducible because websites evolve over time. So some of the issues were reported, like we went all the way back till 2016, so obviously websites have changed a lot. And this is a problem if you want to do a machine learning-based approach to detect breakage because you need data to train your classifier. So if you look at the existing approaches to breakage detection, it can be broadly categorized into three. You have the manual checks, which is what a lot of the filter list maintainers do, which is go to the website and check. The second thing is heuristics. So you have some works that try to count, for example, the number of ads and non-ad elements with and without the filter list, or they count the number of network requests that occur, or they try to visually compare like screenshots of a web page before and after applying a filter list. And then finally, you have machine learning based solutions. As far as we know, not many solutions exist. We could only find one, which is work from Brave, which was a couple of years ago, using the page graph system, which one of the previous talks actually mentioned as well. And some of the limitations of these methods, of course, with manual checks, you have the scalability problem. The other thing is that heuristic-based methods can be affected by page dynamism, so it's probably not ideal to define like numbers of breaking, non-breaking elements. And heuristics and machine learning methods at the moment are only applicable to certain kinds of breakage. So they might not identify breakage that is triggered by user interactions. They might also not they might not detect breakage that is triggered by element hiding rules. So what we wanted to do was to build an ML-based detection approach for breakage caused by these addition of new filter list rules that hopefully tries to address some of these limitations of existing approaches. And the main thing that we observed was that breakage is very closely linked with the user's experience, and we wanted to try and capture that in our system somehow. And this is how we developed this system that we have temporarily named as SINBAD, but this can change. And this is based on the concept of web page saliency. So I'm going to talk a little bit about web page saliency. So saliency originally is in computer vision, and it's basically looking at images and looking at what are the most relevant parts of an image when a user looks at it. And web page saliency is sort of its own subfield because users interact with websites very differently than they interact with images, for example. So the point of web page saliency is to identify regions on a web page that are relevant to your user. And we identified two benefits of identifying these salient regions. One is that if there is a breakage in a salient region, this is probably more important to a user. And the second thing is that users are more likely to interact with elements in salient regions. And this actually leads to two different benefits. The first one is that we can conduct more relevant detection of breakage. And the second benefit is that we can use this identification of salient regions to trigger dynamic breakage or breakage caused by user interactions. So this is a quick overview of our system. So I'll talk about each of them in more detail. But basically, you have a web page that is fed into a salient region detector. And then we have an interactive crawl, which leads to a bunch of subtrees. And then we use those subtrees to feed into a classifier that can detect a page as broken or not broken. And I know that there are a lot of elements on this picture, so I'll describe each of them in a little more detail. So the first part is to actually identify the salient regions on a web page. So what we do is something called semantic segmentation. So semantic segmentation means to identify very closely linked visual elements on a web page. That means, let's say you have a login form, all the elements associated with the form, such as the fields and the buttons and so on, one of them would be a semantic block. We consider it as a single block. And there are a couple of deep learning methods that are used to perform segmentation on these pages, but we actually found that Microsoft has this system called WIPS, which performs segmentations from 2003, and that already performs pretty well. We had to make some modifications to WIPS to account for changes in web pages that have occurred over the years. For example, introduction of more visual elements, iframes, and so on. But basically, we use this modified version of WIPS to segment the web page into blocks. And then we fed this into our saliency detector, which we created, to detect whether each of these blocks are salient or not. And I'm just giving a small example. I don't know how clear it is, but this is, let's say, an example of Twitter's web page. And you may see like little red boxes there on the page. So this red box kind of considers, like one red box is basically one block in this image. And what we do is we made a tool for manual annotators to actually read this salient block and annotate whether they think that this block is salient or not. And we use that as ground truth for our saliency detector. So what we do is segment the page into different blocks, and then we calculate a bunch of features related to the positioning and the content of these blocks and all the DOM nodes within the blocks. And then we feed that into a saliency detector, and the labeling of these blocks has been done by our manual annotation tool, which we provide to a bunch of annotators. So once we have the salient blocks, we run crawls of different web pages. So what we do is we run 3 crawls per web page, 1 with no filter list applied, and then 2 with the broken version of the filter list and the fixed version of the filter list. And then these crawls have an interactive element associated with them, where the crawls actually are provided with which blocks are salient, and they perform some interactions. Right now, they're basic interactions, like if it's a video, play the video, and so on. But this can be expanded to take more complicated interactions into account. And then this results in trees that we have, and these trees consist of the DOM nodes as well as enhancements such as the requests that are sent during the loading of the page, some of the errors that are generated, and so on. So once we build these enhanced DOM trees, what we do is we create edit subtrees, and those are basically what are the differences in the trees that occur when we move from one crawl to another. So for example, when we generate a tree with, let's say, with a broken version of the filter list, and then we move to the tree with the fixed version of the filter list, what are the changes in the trees that occur? And these changes are called edit subtrees. And I'll just show that with a small example. So let's say that you have a tree like this without the filter list rule. And then when you apply a filter list rule, you see that the image, there's no more request being sent out, and the clicking of a button generates an error. The subtrees that occur here are these 2 subtrees, which consist of all the elements that changed between these two crawl settings. So what we do is we generate these edit subtrees over these multiple crawls for different pages, and then we label these subtrees based on the transition between the crawl scenarios. So we have a number of conditions for labeling, but it's something like if you have a filter list and then the subtree got removed on addition of the filter list, then probably it's maybe a legitimate add, and so on. So I'm happy to talk about what are the different kinds of conditions we have, which are used for our labeling. So now we have the subtrees, and then we have the labels for the subtrees. So we extract a number of features from these subtrees regarding their content, their saliency, their structure, and their functionality. And then we feed this into a classifier, which is a random forest at the moment. And then we classify the subtrees on a page as whether they're broken or not. And now, how do we move from subtrees to whether classifying a page as broken or not? And this can really depend on the use case. So for example, you can define a rule that says that if there is at least one broken subtree on a page, then the page is broken. You can have thresholding. So You can have minor breakages if there are only a few number of broken subtrees, or major breakage if there are a large number of subtrees, and so on. So this is something that can be tuned. So we did a preliminary evaluation, so where we had about 430 sites, which resulted in 4,600 subtrees or so. And we labeled these into broken, legitimate, and neutral, where broken is broken. Legitimate means that this was actual removal of an ad by a filter list, so a legitimate use of the filter list. And neutral is any kind of changes in the subtrees that are caused by just the page changing with time and not necessarily the filter list. And our initial performance shows about 70% accuracy in detecting broken subtrees. And one of the biggest challenges that we have had so far has been we have very limited broken samples. So if anybody has ideas or data sets that they would like to share, we are happy to have them. Yeah, and as this is in-progress work, we also have a few other things that we are currently working on. Some of the things is improving the saliency detector. So we now we are passing our saliency annotators to a bunch of people in order to obtain more annotated data so that we can improve the saliency, as well as the segmentation tool. So we are trying to see how we can improve the semantic segmentation process. We are also working on improving the features for the classifier for breakage, and then also after that we will manually verify some of these results. And then we are trying to measure what the benefits of saliency are, because saliency could not just improve the detection of breakage, but it can also maybe reduce the number of interactions by showing you what parts of the page are probably the most relevant to interact with. And finally, we are doing comparison with alternative methods, mainly Brave's system for breakage detection. So in short, we created this system called SINBAD. This is very much a work in progress. And we are seeing promising results, at least initially. But we do have a big issue, which is limited data samples, and also the issue of reproducibility. So since web pages evolve with time, we haven't found a good way to reproduce old examples of web pages so far. And also, as part of this work, we've also created a lot of tools. There's a breakage detection system itself, but also this tool for people to label what are the salient regions of the system. And we also have this tool for analyzing user reports of breakage quickly, and we'll be releasing that, and hopefully it will be useful to the community as well. And we envision that this system can be plugged into other systems. For example, we had AutoFR with Hue, which has a breakage component, so you can ideally plug this kind of breakage detection system into that and help to form filter list rules and also detect breakage on the side. Thank you very much, and I'm happy to take questions.
Wow, a couple out there. Where is the catch box? Who is? So it falls to you. Hands up, everybody. Who do you want to throw it to? Oh, I was expecting it across the room. Anyway, please.
So you have mentioned, first of all, thanks a lot for the presentation. It's very candid. You have mentioned a limited data set, and I would assume that ideally you would expect the data set to be limited, otherwise it means a lot of things are breaking. So I'm wondering why the data set is so limited, because you are primarily working with crowdsourced lists. Mm-hmm. That means every day a whole bunch of pull requests are coming in, and each entry could be potentially a rule that breaks something somewhere. So just hooking onto this contributions pipeline, this could be, this gives you unlimited data potentially, is it not?
You mean looking at the GitHub comments directly mm-hmm. as well? Yeah. One of the things that we noticed was that we found that looking at the forums instead of the GitHub comments was a little more accurate, because some breakage is actually caused by multiple filter list rules, and you need actually to know the set of GitHub commits to reproduce the breakage itself. So if you look at the GitHub commits individually, you might not be able to reproduce the breakage. This is something we saw. I think Brave, for example, looked at the commits directly, and we saw this as a limitation of the system. I don't remember the numbers, but Saeed, you might remember how many cases we had where multiple commits led to one issue.
Give the mic, and maybe if you could introduce yourself real fast to everybody.
Yes, I'm Saeed. I'm collaborated with Sandra on this project. It was around 30%, I believe, something like this, whereas a certain issue is not resolved until you have multiple commits. So if I only look at the commit and the commit before it, I didn't actually get the broken one and the fixed one. I got an intermediate one. So that's why a forum issue is a better representation of the issue and the solution.
So we got one in the front here.
Hi. Thank you so much for the presentation. I just wanted to say that what you're doing is very important, and that it's very important for ad blocking companies to have such an instrument that would reliably detect breakage. We haven't yet found any, but if you can, if you can improve in your work and finally give something to us, it would be so great. And regarding the data set, you should probably also take a look at current filters GitHub. We have like 150,000 issues there. And okay. I suppose that there are some breakage as well.
Okay. Oh, yeah, sure.
Go.
So I was looking at with the interactive part of it, how does it deal with logins? So say, for example, there's a breakage, but it requires a login to see said breakage. How does the interactive part, do you have to actually have a set of logins for these sites to actually work?
Yeah, this is something we've been discussing. So far we've kept the interactions a bit simple, and mainly it involves like clicking or maybe like typing in random text into boxes. So we are thinking of incorporating login. There is some work, related work on like detecting tracking and so on that has like automated crawls with login functionality incorporated into that. So we are wondering whether it makes sense to take some ideas from there, but we don't have a good solution yet. But we would like to include login as well.
Does it affect when you crawl sites? Do you hit any anti-bot detection techniques? Like I know that Cloudflare you might hit Cloudflare warnings if you start crawling too much websites.
So far we have not. We are using the OpenWPM crawler, which does some sort of automated scrolling and things like that
right.
to beat the bot detection. But yeah, we haven't encountered this so far in our crawls.
Should have time for one more. Judiciously not looking to his right.
All right. Hi, Sandra.
Hey.
So, thank you for the interesting presentation. So I have a couple of questions. If time permits.
Let's make it a 1.5 part,
Yeah.
if we can.
So
Yeah.
the first one has to deal with the saliency features.
Yep.
Because saliency, I presume, is something subjective, right? What is salient to me might not be salient to the other user. So while you were annotating those pages, did you have multiple users annotating the same page, and what was the inter-rater agreement there?
Yeah, so this is something that we are currently working on. So initially we just had like one person annotating, and that's poor Saeed who had to annotate a lot. Now we are actually releasing the tool to about, we are aiming for about 10 annotators, and we'll let you know how that goes. It's in progress at the moment.
All right. The quick short one, if I may.
Yeah, I said 1.5.
Yeah.
So you got it.
Yeah. So since you're already using the random forest to classify the breakage, so given the set of features that you have, which are the important ones that you have identified among the structural, saliency, and content-based ones?
I think the saliency feature was quite important, if I recall. Saeed, maybe you were.
It was maybe.
Yeah, you have.
It was maybe fourth or fifth important ranking. Other features include structure features, where it says in the graph, and other stuff related to, I believe, the node type too, of course. So node type is important, structure, and then saliency appeared there.
Okay.
Wonderful. Great questions, great presentation. Thank you, Sandra.
Thank you.